Hello, all. Good evening. Welcome for the next session on algebra. So, today's topic is coordinate geometry. So, we'll be looking at, questions related to graphs because coordinate geometry is all about what? Sketching of functions, right, on the xy plane. And we have looked at so many different functions so far, the different types of equations and their related graphs we have already seen. So all of us are by now aware of the standard functions and their graphs. Questions on coordinate geometry are typically based around equation of lines, trying to find the points of intersection. More so, the recent questions that we have seen, they are based around some equations are given of some functions, and we have to find some area of the region that is bounded by those curves. So curve sketching is fundamental to mastering this topic. Again, we have brought a mixed bag of questions, so I hope you are all set up and ready to uh, learn and try with me. All right, so without further ado, let's start. But before we start, one quick reminder: we are live now with our mobile app, both on Google Play and Apple Store. So, as you have been enjoying our different ways of reaching out on YouTube, you will find this as well as one of the good things to help you to learn and keep up with your practice. So, make full use of this app as you do with other things. All right. So, ready? Let's start. Let's start with the session. Again, we'll be looking at a mixed bag of problems. Some of them which I have brought along, and some previous year questions as well. Let's see. Here we go. All right. So as I said, it's going to be a lot of dependence or a lot of usage of graphs will be there. So we'll be doing a lot of curve sketching. So you can see this question. Okay, I'll give you a minute to try, everyone. Just 1 minute. Yes, we have a lot of people in the session. So try this and let me know if you get the answer. All right. Yes, I know you can do this. See, we have studied these equations and their graphs already. So now let's see. Okay. So y equals x square minus 5. It's a simple parabola, isn't it? And at x equal to 0, the value of y is minus 5. So if I want to plot this, it means that, right, this being the x and the y axis, it's passing through this 0 comma minus 5 here, and it's an upward parabola obviously. So it goes up and it's symmetric around the y-axis like this, right? So we have to find the intersections of this graph along with what? Along with the other equation of x square plus y square equal to 25. So we know that x square plus y square equals a square is the equation of a circle with its center at the origin and radius of a units, right? So it has a radius of 5. Okay, identify these points. This is 0 minus 5. Also, y is 0 when x square is 5 or x is plus minus root 5. So these are the points root 5 and minus root 5 comma 0 on the x-axis, right? So identification of the intercepts of any curve is essential to understand its uh, basic it's like important points where it is passing through, so that with relative to this graph, we know since this is a circle of radius 5, so it will intersect the x-axis farther down the line, so it will look something like this. Also, since it's radius of 5, so it will also pass through 0 minus 5. So this vertex of the parabola is also the point where the circle will also pass through. So this itself becomes one of the intersection points. And you see, this was one point of intersection here. So I'm not interested in solving for the point of intersection. I'm just interested in identifying the points of intersection, because that is all that we need to do. By symmetry, there'll be another intersection point over here. And I think that completes the graph. So we have these 1 and 2, and this vertex being the third point of intersection, right? So at vertex, the curves are touching each other. At the other 2 points, they are intersecting each other, right? Point where the curves touch each other is also called as point of intersection. All right. So standard graphs whose intersection we had to identify. So this is a completely a question of graph, right? Okay, I want more participation, please. Let's see if you are able to look at the next one and get this. Okay, so again, something to do with circles and more on circle geometry, because tangents are there. You have to find some x coordinate of some point P. Yes, again, I know you can do this. Please try. Okay. So I'm discussing, but I'll be waiting. If you get the answers, do let me know on the chat box. Now, so tangents are drawn from a point on the x-axis to a circle. So we don't know, we are not given the equation of the circle. All we know that there are two tangents drawn. So I'm just going to draw the tangents which he's talking about. P is a point on the x-axis, right? P is a point on the x-axis. So somewhere there is a point P, and there's a point 3 comma 5, and there's another point somewhere 9 comma 10, and tangents are drawn. So PA and PB are drawn. That's all that we know. Circle is passing. Obviously, A and B are the points of tangency. So what do we know in this situation? What do we geometrically know? What condition should be satisfied? Yes. What condition? What do you know about tangents and circle? We know that from an external point to a circle, two tangents can be drawn, and those tangents are always equal in length. So this point P being on the x-axis will be something like a comma 0, where a is any point on the x-axis, a comma 0, any point on the x-axis has its y value 0. So a comma 0. So can I say that the geometrical condition which must be satisfied is that the distance P and PB must be the same? So 3 comma 5 and 9 comma 10. The distance of these 2 points from a comma 0 is the same. We can write an equation for this, and we can get the value of this a. That is exactly what the question is asking, the x coordinate of point P, which is this value a, right? So just write this equation. Distance we know is under root x2 minus x1 whole square plus y2 minus y1 whole square. So I'm just writing PA square equal to PB square, removing the square root. And I'm writing a minus 3 x2 minus x1 the whole square plus y2 minus y1. So 0 minus 5, or simply 5 square, is a minus 9 the whole square plus again 10 minus 0, or simply 10 whole square. So this is a simple quadratic which you can easily solve. Go through the process of expanding and solving. You eventually get the value of a as 12.25 on solving this and expanding this equation. Isn't it? I think all of us are very familiar on how to solve such equations, right? So the point is, coordinate geometry is application of geometry to a large extent. So all the basic geometrical concepts will be applied also, such as this one in coordinate geometry, right? So from the circle property, which is that we know that the length of tangent is the same to from an external point, that property is applied over here, and using the distance formula we get the required value. All right. Okay. So as I promised you that I've brought a mixed bag of problems, all the different varieties. So now a very different kind of a problem, you know, directly on the idea of coordinates. So this question is saying, consider the triangle bounded by the lines y equals 3x, x plus y equals 40, and the x-axis. Three lines form a triangle, and he has given the equations of those lines. How many points lie on or inside this triangle with integer coordinates? Very interesting question. And this kind of question has been asked. Okay, so let's see. Well, let's say this is our xy axis. So we need to plot the lines and identify the triangle. Y equals 3x is a line passing through the origin with the slope of 3. So it will be quite steep. Y equals 3x. The line x plus y equals 40. Drawing it with a different color. So it will be passing through 40 comma 0 and 0 comma 40. So let's say it starts from somewhere here, and it will cut this line obviously somewhere, and it will proceed further like that. All right. So obviously we are interested in finding this point of intersection. This is the triangle that we have x-axis is the base of the triangle. Okay, so this line y equals 3x and this line x plus y equals 40. Where do they meet? Not difficult to understand that x plus y is 40, so y is 3x, so 3x plus x, 4x is 40, x is 10. X is 10 and y is thrice of that, so y is 30. So this point of intersection is 10 comma 30. Now we have to find we have to count, right, how many points lie with integer coordinates. So there will be so many points like 0 comma 0 origin itself, this point 40 comma 0, this point also, all the points on the boundary of the lines, the sides of the triangle, inside of the triangle, so many points. So we have to count them, right? It's a counting problem. Okay, so how do we do? We just, you see, what we can do is we can find that, or we can see horizontally the base of the triangle, right, starting from origin to 40 comma 0. Can I say these are 41 points on the x-axis from 0 0 to 40 0? So as the values of x proceed from 0 to 40, right, there will be corresponding values of y that we will get. So all the integer values of y corresponding to each value of x will be the number of points. So we can count them, and perhaps there should be a pattern so that we can count them easily, right? So let's do that. When x is 0, y can only be 0 on the triangle or inside the triangle. So this is 1 point. When x is 1, since this is the line y equals 3x, so when x is 1, what will be y? Y will be 3 on the line. So can I say from 1 0 to 1 3, these are values of y going from 0 1 2 3, which are a total of 4 points. Likewise, when x is 2, so on the line y is thrice of that, so this is 0.2 comma 6. So the values of y are 0 1 2 3 up to 6. From 0 to 6, these are 7 values. Can you see that 1 4 7, this is an arithmetic progression, right? We can count them, we can add these number of points by this sequence. Let's see one more time. When x is 3 comma 0, and this is 3 comma 9 on the line. So all these points are from 0 to 9, which are 10 points. Again, following the same sequence, 1, 4, 7, 10. It's a AP with a common difference of 3. And so on until we reach this point 10 comma 30, right? When x is 10. So again, when x is 10, takes the values from 0, 1, 2, 3 all the way up to 30, which are 31 points. So we can add this sequence. This is one group of points. After we cross x equals 10, after that, there's a different pattern because a different line comes across, right? Okay, let's first add this and then we'll also see what happens from 11 and onwards. So these points are the number of points that we have in total in the first phase is 1, 4, 7, 10 all the way up to 28, 31, the sequence. How many terms these are? Because in AP we have to find the number of terms to be able to add the terms. So this is 3 into 0 plus 1. This is 3 into 10 plus 1. All the terms are of the form a multiple of 3 plus 1. So 3 into 0 plus 1 and up to 3 into 10 plus 1. These are 11 terms. These are 11 terms. So AP summation is number of terms by 2 into first term plus last term, right? N by 2 into first term plus last term. First term plus last term 1 plus 31, 32. So 11 into 16 therefore 11 by 2 into 32. So these are 176 points that we get. All right. Likewise, let's understand what happens as x proceeds from 11 and onwards. Okay, let me write this here. X, y, and number of points. So when x is 11, okay, so this is 11, 0. Obviously, this being x plus y equal to 40. So when x is 11 on this line, y will be 29. This will be 11, 29. So y is going from 0 to 29. 0, 1, 2, 3 up to 29. Which are how many points? These are 30 points, 0 to 29. Now, when x is 12, 12 comma 0, and this will be 12 comma 28. So 0, 1, 2, 3 up to 28. So these are 29 points. So you see, this line is with a slope of -1. So therefore, we are getting a common difference of 1 over here. See, this line y equals 3x was with a slope of 3. Hence, we got this common difference of 3. You can again check when x is 13, right? This will be the point 12, 13 comma 27. So again, from 0 to 27, these will be 28 points. So this is a very simple sequence of 30, 29, 28, all the way up to at the very end when this will be 40. So there will be a single point y equal to 0 and a single point on the triangle. So this is, can I say, what we need to add here is simply the summation of the first 30 natural numbers 1, 2, 3 up to 20, 30. These many number of points are coming from the second part of the triangle. Basically, I've divided the counting into two parts. One before and up to 10 and one beyond 10, right? So here we got 176 points. Here in this phase, we are getting these many points, which is 1, 2, 3, and so on up to 30, which is simply summation of first 30 natural numbers. So n plus 1 by 2 is the formula for that. So 30 into 31 by 2. So 2 cancels and this is 15 into 31. So 31 into 15 will be 465, right? Okay, so that is what we have, 465 and 176, which is how much? 864145641. 641 points are there. Okay, so I think this kind of question was asked. Okay, it's a replica of a previous year problem, and yes, so pattern recognition is there in this problem, right? Sequence is there, and yeah, very much a doable problem once you understand how to do this. Okay, back to equations and their graphs. As I said, a lot of recent year problems have been built around finding the area enclosed by some graphs. Okay, so what is the area enclosed in square units between the curves mod y equals x minus 1? Remember, mod y equals x minus 1, not y equals x minus 1. So what's the graph of this? You have to think. And twice of mod x plus thrice of mod y equals 12. Modulus related graphs and their equations have are coming are very relevant, and many different varieties of them are there. So these two different varieties of equations we have. Let's understand how to sketch them and how we'll get this area. So you see, whenever we have such questions, you have to plot all the graphs, understand the boundaries, okay, of the graph, and hence identify the region whose area is to be obtained, and then apply basic geometry to find the area. Typically, the regions obtained are triangles, rectangles, basic figures. All right. So mod y equals x minus 1 means mod is never negative. Can I say for this graph, this expression x minus 1 can never be negative, because we have mod y equal to this, mod y must be positive. So x minus y must be positive, or x minus 1 is greater than equal to 0. So x is greater than equal to 1. So this graph will only be defined for values of x 1 and more, not before that. So this graph is a restricted graph, only working in the domain of x being 1 or more. And when that happens, we have obviously y is plus or minus of x minus 1, because that is the basic way we deal with any modulus equation. Mod y, mod of something, mod y equals something, so y is plus minus of that thing. So it looks like this graph basically will consist of two lines, two straight lines, but they are restricted. They are not lines in the sense being infinite on either side. Okay, it's more like a ray, I would say, because it starts only from x equal to 1 and then goes further. And this one, 2 mod x plus 3 mod y equal to 12. So let me start doing the sketch first of all. This one I'm drawing in. So I'll draw the two graphs with different shades so that we can identify them easily. So y equals x minus 1 will be this line starting from 1 comma 0, and y equals minus of x minus 1 will be this line with the slope of minus 1 going down like that, right? Okay, now this one, 2 mod x plus 3 mod y equal to 12. All of us should know this is a standard graph. This is a very I mean the graph of this is like this. The graph of this one is a rhombus. The shape of this graph is a rhombus with its center as the origin of the coordinate plane. So mod x by a, I'm generalizing the discussion, mod x by a plus mod y by b equals 1. The equation, the graph of this equation is a rhombus whose four vertices are the points plus minus a comma 0 on the x-axis and 0 comma plus minus b on the y-axis. So in this case, if we reduce this equation to this form, so can I say, we can say that what we have is mod x by 6 plus mod, right, from this dividing by 12, mod x by 6 plus 3 mod y, so mod y by 4, 3 by 12 equals 1. So on the x-axis, this is 6 comma 0. Remember, this was 1 comma 0. This is 6 comma 0. And this will be a rhombus looking like this. Okay. Now I'm actually, this graph will go, till here and like this. The whole rhombus I'm drawing just for understanding. So like that. Okay. This is 6 0. This is minus 6 0. This is 0 4. This is 0 minus 4. All right. So this is the area, basically this shape, which this boundary which I am highlighting, right? Obviously, these are two congruent triangles above and below. By the symmetry of the figure, it is very symmetric, right? So the area of the shade, the area that we need is that of these two congruent triangles. We can simply double the area of the upper triangle, let's say. So right, so base is from 10 to 60, so the base is of length 5 from 1 to 6, and so that is the base, and we can find the height by finding the point of intersection of these two graphs. So we can easily find that, because we know that when x and y both are positive, so this is the line 2x plus 3y equals 12. See, the reason we get this rhombus, let me explain how do we say this is a rhombus. Because you see, mod x and mod y will open with plus and minus signs. So when x and y both are positive, which is in the first quadrant, we get this line 2x plus 3y equals 12. When x and y both are negative, in the third quadrant, we get the line minus 2x minus 3y equals 12, which is this line 2x plus 3y equals minus 12. And similarly in the other quadrants, right? So that's how we get this shape of the rhombus. Hence, 2x plus 3y equals 12, and this line, which is y equals x minus 1, this one, they are intersecting. So we need to find this point of intersection. So replace x as y plus 1 in the other equation. So twice x, so twice of y plus 1, right? Replacing this in this equation. So twice of y plus 1, 2y plus 2, plus thrice of y is 12. So 5y is 10 or y is 2. So therefore this is x is y plus 1. So this is 3 comma 2. X is y plus 1, y is 2, x is 3. So therefore the height can I say is 2. So the area of this triangle is half into 5 into 2 is the area of the triangle. For the double, we have to, for the below triangle, we have to take twice of that, which is we get 5 into 2, 10, right? So 10 square units is the area. All right. So we looked at modulus equations and their graphs, right? All right. Time to look at some previous year questions now, people. Yes, buck up, buck up. I need some participation now. I'll give you 2 minutes for the next problem. So please, yeah, I think all of us can get this problem. Very basic application of geometry is there. So please try this. I want some. I want some participation by now. Yes, I know you can do this. Okay. So the figure is already given. It's a parallelogram. You can see that the base OA, the vertices are mentioned. Origin is the one of the vertices, and then 7 comma 0. So can I say that the base of the triangle is of length 7? The area of the parallelogram is given as 21. So what's the formula for the area of a parallelogram? Area of a parallelogram is base into height, right? Parallelogram is simply twice of a triangle. Area of a triangle is half base into height. Area of parallelogram is base into height. Base is 7. The length of the base is 7. Height must be 3. So if I draw this altitude must be of length 3, because 21 is 7 into 3. Area of a parallelogram is base into height. Base is evidently 7. Height therefore must be 3. So this point C will have the y level of 3. Okay, finally, I got some answer. Yes, that's correct. Funny name, but yes, that's correct. All right. So So the y level is 3, and the question also says that the point C lies on the line x equals 3. So here C, for the point C, x is also 3, and obviously then y is also 3 because of the height that we know by now, right? So 3 comma 3 is point C. So what is point B? Obviously we have to move 7 units further horizontally because base the opposite sides are parallel. So we'll just go further 7 units down the line horizontally. Y will still be 3 and x will increase by 7. So this is what, 10 comma 3, option B, right? So as I said, some questions on coordinate obviously are application of geometry. A very basic level of properties are required to be applied. Okay, let's see. Next one, graph area CAT 2005 question. Fine. So yes, good. I got some response in the previous question, which was correct. Let's again try this one. Remember, very basics of modulus, apply that. You'll get it. See, I don't want this session to be a monologue. I don't want to just keep on solving the questions one after the other, right? Let's try this. Let's see if we can get there, right? No point in just rushing through the problems. Well, so what do we do? See, it's not difficult, people. Uh, you open the modulus, you know, based on the input being positive or negative. When the input is positive, you open it as it is. When the input is negative, you open it with the minus sign, right? So whatever is written inside the modulus, consider that being positive and negative. So x when x plus y is positive and when x minus y is also positive, this equation will open as x plus y plus x minus y equals 4, or simply 2x is 4, or simply x is 2, right? But remember this, the graph of this equation is not simply the whole line x equal to 2 from minus infinity to plus infinity. No, this is a restriction. There is a restriction implied that x plus y should be positive and x minus y should be positive. Try to understand. Which means that you see, this is the, so on the graph, okay, so let's say that this is the line of x. So this line which I'm drawing is the line x plus y equal to 0, right? Y equals minus x. This is the line which is, this is y equals 0 x, sorry, let me correct that. This is obviously the line with the slope of 1. So this is the line y equals x, and this is the line which is this line going downwards is the line x plus y equals 0. All right. So we have x equals to 2, but it will be restricted between these two lines, which means x plus y is more than 0 above this, and x minus y is more than 0 below this. So it will be bounded between this. So it's not going to infinity and minus infinity. So we do have the line x equal to 2, but bounded within y equals x and y equals minus x. So this is the point 2 comma 2. This is the point 2 comma minus 2. And similarly, you keep on opening this as per the different restrictions and open the modulus, right? So when this is positive, positive, the first term and the second term both are positive, positive, we open it like this. When let's say both the terms are negative, which means x plus y is negative and x minus y is also negative. So they open as minus sign. So minus of x plus y and minus of x minus y, which is minus x plus y, is 4. Or again, simply we are getting minus 2x is 4, or x is minus 2. X is, this is minus 2. All right. So again, we do draw the line x equals minus 2, but again, within this restriction, within this bandwidth, right? So this was the line x plus y equal to 0. Below this is x plus y less than 0. This was the line of y equals x. Above this line, we have x minus y negative. So in this way, similarly, when you take the signs in another way, which is positive, negative, and negative, positive, and you open the modulus. So likewise, you get when positive, negative, you say x plus y, negative, so minus of x minus y. So minus x plus y is 4. So 2y is 4. So y is 2. And likewise, here you get y is minus 2. Hence, you complete the figure and you get a very beautiful, very nice, simple 2, a square passing with its vertices at 2 comma 2, 2 comma minus 2. And likewise, this is minus 2 comma minus 2, and this is minus 2 comma 2. So obviously it's a simple figure. It's a square of side length 4, because either horizontally or vertically, you have this distance of what? 4, going from y equal to minus 2 to plus 2, going from x equal to minus 2 to plus 2. 16 is the area. It's a simple square of side length 4. You just had to open the modulus. You just had to sketch it within the restrictions, right? So we learned another graph with this mod x plus y plus mod x minus y equal to a constant, right? Is a square with its with origin as the center of that square. All right. So coordinate geometry is therefore all about sketching, as I said in the start, right? So let's take one last problem for today's session. People, okay, let's do this. This came very recently, CAT 23. The area of the quadrilateral bounded by the y-axis, the line x equals 5, and the lines. The question itself is saying that the following graph should give you the equation of at least 2 lines, if not more, which is the difference of two modulus expressions, mod x minus y minus of mod x minus 5 equals 2. Y-axis is simple, x equals 5 is also simple. Both of them are simple vertical lines. It is this graph that we have to understand. We just learned how to open the modulus. That's all that we need to do. Modulus opens with a plus sign when the input is positive and with the minus sign when the input is negative. Let's see. Okay, so let's say this is the y-axis and let's say this is the x-axis, people. Right. Let's see what we have to do. X and y-axis. Now, so y-axis and the line x equals 5. X equals 5 is a vertical line at the distance of 5 units away from the y-axis, passing through 5, 0. So basically, the graph is limited within x from 0 to 5, essentially. And we have now this graph. So this graph basically we have to sketch within the range of x from 0 to 5. Now this term, therefore mod of x minus 5, is very interesting because I know that I'm drawing the graph in the range of x from 0 to 5. So obviously mod of x minus 5 is simply what? Since we are in the range of 0 to 5, which is less than 5, so mod of x minus 5 will be negative. When x is between 0 to 5, x minus 5 will be negative. So this will open as 5 minus x. So actually, we can replace this with simply 5 minus x. Hence, our equation, at least one level of simplification happens, that mod of x minus 5, and let me take this term on the right hand side, is mod x minus 5 plus 2. And as I said, this is simply 5 minus x. So this is 5 minus x plus 2, or 7 minus x. This is x minus y, right? Okay. Now, it's mod x minus y. What does that tell us? We have to open this modulus depending on whether x is more than y or x is less than y. When x is more than y, then x minus y equals 7 minus x is the equation, which is a simple straight line. Just rearrange this and write in the form of y equals mx plus c form. So take y here, y equals x comes here, x plus x 2x, and 7 comes here, minus 7. I can sketch straight lines if I write it in the form y equals mx plus c. M is the slope, c is the y-intercept. So this line is passing through 0 comma minus 7. Minus 7 is the y-intercept. So somewhere down the line, somewhere below, we'll have the point where this line is starting from 0 minus 7. Y equals to x minus 7, and with a slope of 2, so rising sharply with a steep ascent, it will be like that. Also, I can mark the x intercept and the point where it will intersect with the line x equals 5. So when y is 0, 2x minus 7 is 0, or 2x equals 7, so x equals 7 by 2. So 7 by 2, or 3.5, is this intercept, 3.50. Maybe I'll need these points for the finding the area. And here, so this is x equals 5. So in this equation, y equals 2x minus 7, when x is 5, what is y? Y is 5 into 2, 10 minus 7, 3. So this is the point 5, 3. Perfect. Very nice. But remember, this equation is only drawn when x is more than y. Now look at this, that in all these points that we have drawn, from starting 0 minus 7 up to 5, 3, x is always more than y. X is always more than y. 0 is more than minus 7. 3.5 is more than 0. 5 is more than 3. So this line is valid in this range, right? Perfect. So this is the boundary. This is one of the boundaries. We need another boundary to finish the quadrilateral. And for that, we need to have x being less than y. And when that will be the case, so this mod, remember, this is the equation that we are working upon. Mod x minus y equals 7 minus x. We are opening it in two different ways. When x is more than y, we get this line. When x is less than y, now we are opening this modulus in its form. So mod x minus y will become y minus x. And that should equal this 7 minus x. This time minus x cancels. We simply get y equals 7, a very simple horizontal line. Quite above here, from starting from 0 comma 7, we have the horizontal line y equals 7. So till the point it meets with this line x equals 5, do we still have x less than y? Well, this will be 7 comma 5. So yeah, very much y x, which is 5, is less than 7. So we get this. What does it look like? What does this boundary look like? Can you see this quadrilateral now? Can you see this? Let me shade this with this zigzag line. This line, this is the boundary. This is the quadrilateral. So what is it? Is it a specific kind of a quadrilateral? Yes, obviously this vertical line x equals 5 and the y-axis are the parallel lines. So at least I can say it's a trapezium. So what's the area? Area for trapezium, half into sum of parallel sides into the distance between them, right? So what area do we have? Remember, it's a theta question. So sum of parallel sides. So look at this. This side 0 minus 7 up to 0 7. So y value is increasing by 14 from minus 7 to plus 7. So this side is of length 14, this side. And here 5 3, sorry, this is 5 7. I just swapped that. Just one second. This is 5 7, obviously not 7 5. X is 5, y is 7, right? So from 5 3 up to 5 7, this is a distance of 4. Y is going from 3 to 7, 4 units, right? So therefore that is 4. So these are the parallel sides, these are the length of the parallel sides, 14 and 4. Half of sum of parallel sides into the distance between them, which is means this distance, right? So this is simply from 0 7 to 5 7. We are moving horizontally by the 5 units between the two vertical lines. So that's what we have. 14 plus 4, 18 by 2, 9, 9 into 5, 45. That's what you need to type in. All right. So I hope this again, I have taken you on a journey where we have understood how important is curve sketching. From day one, I have been saying algebra is both working with variables and equations, and parallelly, sometimes we are required to do graphical analysis. We have done that with the topic of functions and graphs also. Okay, so that brings me to a conclusion actually on the segment of algebra. But don't worry, I'm not going to leave you. We're going to start with a fresh series, which is 150 must to do questions. So stay tuned, and we'll be starting with a series of problems, which will be all the different variety of questions from all the different modules: arithmetic, algebra, numbers, geometry, modern maths, right? And looking at those questions which are on the current pattern and are must to do, right? So I'll see you on that, and all this will continue further, right? So as I said, uh, stay in touch and stay connected, and see you soon, right? See you soon. Thank you so much. It has been fun for me, and I hope for so that it has been so for you as well. Thank you so much. Thank you, people. Thank you all. Thank you.